Okay, so we're going to start going over the review. A lot of times in the homework, a lot of people lost out on points on the homework because of exactly what it says to follow the directions. On number 11 there, that's the one that's highlighted in red there, it asks for two things. It asks you to graph it, and then it asks you to identify its domain and range. Well, if you graphed it without using any points, you're not getting credit for that. You got to have some points. You can't just like rough sketch it. Bless you. Secondly, it asks for the domain and range. So those are things that we need to find. So notice that here is number 11, and that's the function up top. Bless you. Okay, so notice that one of the things is that I'm going to have to pick x's. Like I have to put x's in and see what the y values would be. So one of the things that I'm going to try is I'm going to try numbers like -1. Let me try like negative numbers. Let me try some positive numbers. Let me try 0, see what happens. Well, when I take the square root of -1, I get an imaginary number, which can't be graphed. We've never done anything with graphing -1. It's an imaginary number. It's not a real number, so there's nothing that we can do with that. So that's why I put that little x there, is that there's nothing I can do. I can't work this with negative numbers. Like every time I have a negative number, it's going to end up imaginary, and I don't know how to graph that. However, I can take the square root of numbers such as 0. Like I know 0. So I plugged in 0 because I know the square root of 0. It's asking me to do it. The square root of 0 is 0. So I get -0. Well, -0 isn't a thing. It's just 0. So 0 plus 4 is 4, and that gave me my first point. That's this point right there. That's my first point. I'm sorry, wrong one. Here. Secondly, I picked another number that I know the square root of. I know the square root of 1. The square root of 1 is 1, and then it's got a negative on the outside, so it becomes -1. And -1 plus 4 is 3, so I get my second point at 1, 3.
So you just plug it back into like the formula.
All I'm doing is plugging in numbers to graph it. That's all we do anytime we graph, is we just plug in numbers and we can get the points. Now notice that I'm skipping over numbers. I'm skipping over them on purpose because I don't know the square root of 2 and I don't know the square root of 3. So let me skip to something I do know the square root of 4. The square root of 4 is 2, and then there's a negative on the outside, so it becomes -2. So -2 plus 4 becomes +2. That's where I got this set of points. Then I do another one that I know the square root of 9. The square root of 9 is 3. So it becomes -3. And -3 plus 4 is +1. I get these points there. And then I plot those points. Here is 0, 4, 1, 3, 4, 2, 9, 1. And I get an idea of what my graph looks like right here. Now, that's the first part. It is graphed. The second part asks about the domain and range. Now remember, domain and range talks about, when we talk about domain, we're talking about the x values, meaning how far does this go to the left and how far does this go to the right. And when we're talking about range, we're talking up and down. So how far does it go down and how far does it go up? So we're going to do these separately. If you notice, this does not go forever to the left. It goes right through this line and then stop, like to that line, and stops. It never goes further left than that line. And that line is x equals 0. So that's where the 0 comes from. It never went further than 0. So 0 is the smallest number that it goes to when we're talking left and right. What is the biggest number it goes to? Well, it goes forever to the right. That's why we've got a parenthesis and not a bracket on it. The domain is from 0, including 0, all the way to infinity. So that's our domain because that's left and right. Now the one that always gives people trouble is range. How far down does this go? Well, imagine that this is going down, 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 keeps going down, down, down. It's going to go down forever. So that's why we say -infinity, because it's going in the negative direction forever. But how high up does it go? Well, it goes up, up, up until it hits this point right there. And then what is that point? That line right there is the line y equals 4. So it goes up to 4 and stops right at 4. So it goes from -infinity. We're talking up and down when we're talking range, and we're talking left and right when we're talking domain. So it goes from -infinity all the way up to 4. That's our range. It's just interpreting the graph, looking at it.
So how do you know when it's going to be -infinity?
Well, if it's going downward, it's going towards -infinity, right? Like, so here is like, let's say if I'm talking about domain, if I'm going in this direction, it's towards infinity. Mm-hmm. If I'm going in this direction, I can't call that infinity, I'll call that -infinity.
So past like the 0 point.
Same with up and down.
It's like that 0 point where it keeps on going down.
Yeah, if it keeps going to the right, the domain would be it's going towards infinity. If it's going towards the left, that's going towards -infinity. If it's going up, that's positive numbers, that's infinity, and if it's going down, that's towards -infinity right there.
Let's say like it starts off at -1, right? And then it goes all the way to the right. Where you put -infinity.
Well, what are we talking about? Domain or range?
Domain.
Okay, so -1. So domain for this, if I did that one right there, is no different than the one above. It still goes the same left and right. What's changed is the vertical. It's changed how far up it goes, right? It doesn't go as far up anymore. So in this case, that one right there would have the exact same domain. It goes from 0 to infinity. Notice it hit that red line there, that one that we said was 0. But when we get to the range, it goes all the way down forever, so from negative infinity, but it doesn't go up to 4 anymore. You told me to take it up to negative 1. So that would be that one that we just drew there. So this is not part of the problem. That's just one he said, let's make up and check that out. Yes, ma'am?
For example, you see for the x and y, the numbers you put?
Yep.
Can I use that for all my problems?
Nope. Because it's not going to make sense those times. These numbers made sense. Why did I pick those x's? Because I knew the square root of every single one of those numbers. Why did I pick 0? Because I know the square root of 0. Why did I pick 1? I know the square root of 1. Why did I pick 4? I know the square root of 4. Why did I pick 9? Because I know the square root of 9.
No, can I use it for different problems?
No, because a different problem will have a different thing that we're looking for. Look at the next one. Like when we get to the next one, I use totally different numbers. Why did I use them? Because those other numbers wouldn't have made sense in this one. This is asking me for the cube root. Now here's the things that I know the cube root of. Like look, I know the cube root of 1 because 1 times 1 times 1 is 1. I know the cube root of 0 because 0 times 0 times 0 is 0. And I know the cube root of 8 because 2 times 2 times 2 is 8. So I'm going to try to make whatever is in the radical on this one equal to 1, equal to 0. Now, cube roots can be negative because I can have that be negative. So I could do negative 1, I could do negative 8. I'm going for different numbers now because in this case I'm not trying to do the square root, I'm trying to do the cube root. And so it wouldn't make sense to use those same numbers. So if you notice here, I picked these numbers because if I plug in a 0 up there, I get 0 plus 1, which is 1, and I know the cube root of 1. The cube root of 1 is 1. If I were to put in negative 1 up there, negative 1 plus 1 is 0, and the cube root of 0 is 0. If I were to put in 7 up there, 7 plus 1 is 8, and as we showed just a minute ago, I know the cube root of 8. The cube root of 8 is 2. If I were to put in negative 2 plus 1 is negative 1, and the cube root of negative 1, that's negative 1. Bless you. If I were to plug in negative 9 plus 1 is negative 8, and the cube root of negative 8, that's negative 2. So I picked ones that I would know the cube root of when it's all done. So that's what I'm looking for is like, I'm about to have to take the cube root of something. What do I want it to end up as? And when I pick those numbers, I end up at these points here. And it shows me what my graph looks like. Just like that. Now, when we discuss domain and range, remember, domain, we're talking about left and right. So when we talk about how far does this graph go to the left?
Negative infinity.
All the way forever. So negative infinity. When we're talking domain, it goes all the way to the negative infinity. How far does it go to the right?
Infinity.
Positive infinity. So we get from negative infinity to positive infinity, which is every single real number in the world, all real numbers. That's why we put that there, all real numbers.
Both, if you would just put all real.
I'm just saying that you should be prepared that in any situation you might be asked to write it one way or write it the other. Just understand that this encompasses all real numbers. Now range is different. Range, I'm looking at up and down. How far down will this graph go? Just think about it. Like if this thing keeps going down, how far down will it go? To negative infinity. And if it keeps going up, how far will it go? Positive infinity. So again, all real numbers. So this one is totally different. I use different numbers. It has different range than the other one. It has a different domain than the other one. So they're completely different things. So I can't just keep using the same numbers on them. If I keep using the same numbers, I may end up with really hard things. Like if I had plugged in 4 plus 1 is 5, and I don't know the cube root of 5. I couldn't tell you that. So the numbers you pick are got to be numbers that work out well. All right. Then we get to the ones where it asks you to complete the square. So notice that red part there wasn't there before. So what I needed to do was take half of that middle term there, that one that's attached to the x. Half of negative 6 is negative 3, and I square it to get 9. So that's why I added 9 to both sides. Yes, ma'am?
For the graph ones, how many points do you want us to put on?
I think if you want your graph to be pretty like look like it's supposed to, you're going to need about 5 points. So when I factor this, I end up getting, once I complete the square, I get x minus 3 times x minus 3 is 49. I go down and I get x minus 3 squared. I take the square root of both sides. And I end up here with 3 plus or minus 7, which is something I can do. I can do 3 plus 7. I can do 3 minus 7, so I do them. And that's what you're seeing right here, is that our final answers when we do 3 plus 7 and 3 minus 7 end up as 10 and negative 4. So a lot of these will be completing the square here. So notice again, we had x squared plus 18x equals 15. So I left that little gap there. I took half of the middle term, the one that's attached to x. Half of 18 is 9. And 9 squared is 81. That's where the 81 came from. I added 81 to both sides, which allows me, now that the square is completed, I can go down, start breaking it down. X plus 9 squared is equal to 96, square root of both sides, and we get down to x is equal to negative 9 plus or minus 4 times the square root of 6. So two things. Number one is I've already posted these solutions, but you won't see them until 2:30. They're going to post at 2:30 for you guys because I didn't want anyone to sit here and not be doing this with us. Secondly, I'm actually recording this one for us, so now it's the quick version of it. It's not like, if you want to go see how to do these, then go back and watch the lesson. I'm not trying to reteach all those lessons again. That's why we have the lessons. That's why we pay attention to lessons. And you have the videos for them, is so that you can get caught up on the material. This is like the crash course, just like a little reminder. All right, going on to, it jumps to 15 there. So again, completing the square. Half of 14 is 7, and 7 squared is 49. So we break it down there. We get to x plus 7 is equal to plus or minus the square root of 57, and I don't know the square root of 57. I don't know its factors. I can't break it down any further, so it just stays right there. I can't add negative 7 to the square root of 57. That's not something I can do. I can't add a whole number in a radical like that without the use of a calculator. Okay, 19. This just asked me to solve, so I divided both sides by 3 because I'm just trying to figure out what x is equal to. I got to x squared is equal to negative 16. Now here's the key part. When you take the square root of a negative number, remember that you're going to break it down into two things. The square root of negative 1 times the square root of 16. And the square root of negative 1 becomes what? It becomes I. That will always happen every time we take the square root of a negative number. We're trying to get it to look like the square root of negative 1, so it becomes I. And then I get x is equal to plus or minus 4i. Moving on to 20, same thing. Half of negative 20 is negative 10. Negative 10 squared is 100. That's why I added 100 to both sides. By the time we get down to the square root, at this step right here, we're taking the square root of a negative number. So we broke it down. Again, the exact same thing. The square root of a negative number was the square root of negative 1 times the square root of 25. We did that because the square root of negative 1 becomes I. X minus 10 is equal to plus or minus I times 5, which ends up as x is equal to 10 plus or minus 5i. Okay. 21, same thing. Now here we could not factor it. It was set up to look like it could factor, but there weren't two numbers that multiply to give me 30 that I could add to get negative 8. So I moved that 30 to the other side so that I could complete the square. So adding 16 to both sides gives me x minus 4 squared is equal to negative 14. So square root of both sides, again, we're taking the square root of a negative number, and when that happens, we break it down into two parts, the square root of negative 1 and the square root of 14. We do that because the negative 1 becomes the I, and then the 14 we can't break down. So we get 4 plus or minus I times the square root of 14.
No, that goes to the radical, right?
Yeah, it goes in front of the radical, yep. Now, the one that I think is going to be the one that people have the hardest trouble with is, first of all, we talked about this, is that these were those properties of I. Like, here's I to the first power, I to the second power, I to the third power, and I to the fourth power. If you can remember those four, then you can do I to any power, because it's going to be one of those four answers every single time. It's going to end up being I, negative 1, negative I, or 1. And the way that we did that is when you're given an I, like I to the 15th power, since there are four choices over here, we're just going to divide it by 4 every time. So I take that 15 and I divided it by 4. And when I did, I got 3 3/4. And the part that I care about most is the remainder. Whatever the remainder says, I'm going to go to that answer over there. So notice the one that says 3/4 over here, that ended up as negative I. This will end up as negative I as well. But let me prove it to you the long way. Here's the long, ugly way that I would never do it this way. This would take me forever. This is I to the 15th power. I squared times I squared times I squared times I squared, 2, 4, 6, 8 times I squared, 10, 12, 14. That's 15 i's I just drew out there. I squared times I squared 2, 4, 6, 8, 10, 12, 14, 15. Now we know that every time I have I squared, that equals negative 1. So negative 1 times negative 1 times negative 1 times negative 1. Oh, that's not a times. Times negative 1 times negative 1 times negative 1 times negative 1 times I, because that's just an I there. So check it out. These negative 1s become 1. These negative 1s become 1. These negative 1s become 1. And then we get times negative 1. So 1 times 1 times 1 times negative 1 ends up as negative 1 times I, which ends up as negative I. Same thing that I told you was going to equal right there, just by dividing by 4, but that's a much longer way of doing it. Will it work that way? Sure it will, but you're always taking the long route that way. So when I do I to the 7th power, again, I'm going to take that 7 and I'm going to divide it by 4 because it's going to be one of those 4 answers. So 7 divided by 4 gives me 1 3/4. And unfortunately, this ends up as the same answer. I have that 3/4 there, and the one that's 3/4 always ends up as negative I. But if you want to see it the long way, just remember that this is I squared times I squared times I squared 2, 4, 6 plus 1 more is 7. Negative 1 times negative 1 times negative 1 times I is negative 1 times I or negative I. Same exact thing there. Okay, now here are the other things that aren't on the review, but you still need to remember because they were part of the lessons. Number 1 is was the transformations. So let me give us like an easy situation to start off with first. X plus 3 squared minus 2 times minus 4 up front. Let's talk about what each of those numbers do, because each of those numbers has a special thing that they do, and I need to address what each one does. So here's the things that do something. Like each one of these do something. This does something. This does something. This does something. And this does something. There's 4 things happening in this transformation, but we need to know what those 4 things are. Even if you don't know them all, tell me what one of them is. What do they do? I'm asking what do they do to this? When I say transformation, they move it around. They move it up, down, left, right, stretch it, compress it, they reflect it. What's going on here? So let's start. We always start with the up and down, left and right. Which again, we're going to do that last. Like that's going to be, we're going to do these, we're going to move our up and down first. Like this is going to be our very last, but this will be second to last. We're going to deal with these two first. Talk to me about blue and red. What do they do? Do what?
So you're going to move left 3?
Okay, so these two, remember, control left and right, and they're in jail. This one controls up and down. It's not in jail. So talk to me about, let's start red. What does red do?
So down 2.
Okay, it moves our graph down 2 units. That's what the red part does. Because it's not in jail, we can trust it, and outside numbers control up and down. What's that? Okay, so now we're going to deal with the blue part. The blue part is in jail. It has not made very wise life decisions, so we are not going to trust it when it tells us what to do. So what are we going to do? We're going to move left 3. It looks like right 3, but we're going to move left 3 units because it's in jail. It's in those parentheses, so we can't trust what it's telling us to do. Now let's move on to that 4. That 4 is on the outside, and it does something. It's being multiplied by 4, just like when your height would be multiplied by 4. What would happen? Okay, it's a vertical stretch. It's on the outside, so it's vertical. If it were on the inside, it would be horizontal. So it's a vertical stretch by a factor of 4. Got 4 times bigger. If I took your height, and I multiplied it by 4, by a factor of 4, a factor is just a number you multiply by. That's all it means.
Wait, why is it vertical?
Because it's an outside number.
And that negative?
And the negative, what does that do?
Down.
No, doesn't that opposite of x-axis?
Okay, so
It flips it, right?
it is definitely going to be a reflection. So remember that negative is on the outside. So it's going to reflect up or down. So it is definitely a reflection, but be very careful when we talk about what it's reflected over. It's a reflection over the blank axis. So again, if we're going vertical, and let me just show you, if you're going vertical, you've gone from here to there. Which axis did you just cross?
X.
The X. So even though vertical feels like Y, when you go from up to down or from down to up, what you've crossed is the X axis. This is a reflection over the X axis. So we have to be very careful with that one because that one looks very strange. But when you are going up from the top to the bottom, you're crossing the X axis. When you're going from the left to the right, you're crossing the Y axis. It's kind of like backwards from what we think it would be. So that's one example of what you would have to do with transformations. You might have to identify a transformation. But let me make it like ugly now. But remember that because I don't think I can make it that ugly for you. Like I don't think it'll be that bad. You have a question?
Yeah, like all the other practices we did with this, you put it in the square root. You have.
I'm going to do a square root right now. But remember, whatever kind of container it has, it's going to be, it's still in jail or not in jail.
So if it's in parentheses, it's in jail.
If it's what?
If it's in parentheses, it's in jail.
Yeah, any sort of container. If it's those numbers are in a container, then it's like in jail. And okay, let me add one more thing there, and it's gonna be kind of jammed in there, but I'm gonna add that in there right there. So there's a negative out front. I just couldn't squeeze it in there. I guess I could take the time to erase that, and let me do this properly, just so it looks correct. There's nothing wrong with the way I wrote it, but it would look better if we did it like this. Okay, don't freak out. It's the same rules that you've always had, but except for things are in different places now. So remember, things in jail control left and right. Things in jail you cannot trust because they've made poor life decisions. Anything that's not in jail controls up and down. We can trust their decisions. All right.
You go up 3 units.
This definitely is up 3 units. It's going left 2 units.
And since it's inside the root, it goes left. The root count as almost like a parentheses, right?
Yeah, same, any sort of container there.
It's going left, but it's positive, right?
Yeah.
Correct. Now there's 2 things going on there. There's a negative inside there, and there's a 1/2. Neither one of them you can trust.
So it'll be horizontal.
It is a horizontal stretch. Let's talk about that 1/2. I'm so glad you said that. It is because anything inside controls left and right, so this definitely is a horizontal. Now, he said stretch, and you're right. It looks like a compression, right? It looks like if you took me and made me half as wide as I was going to be, it looks like that I was going to be like smaller. But this is a number that you cannot trust, right? It's even though it looks like I'm getting half of my original size, which would be a compression, this is an inside number. We can't trust it. It's a horizontal stretch. Now be careful with this by a factor of what?
2.
By a factor of 2. We can't trust that 1/2. We have to flip it upside down and go with of 2.
But it's horizontal because it's inside.
Yep.
And why is it 2?
Because we can't trust that 1/2. We have to flip it upside down. So it's definitely horizontal. It's inside. And it looks like a compression because if I took half of something, it looks like it's getting like half as big as it used to, like a compression. But this is an inside number. We can't trust it. Now, what do the negatives do? All negatives do the same thing. What do they do?
Reflection.
It's a reflection, but the question is, it's moved from left to right because it's horizontal, right?
So it'll be vertical, so it'll be across the Y.
So so if you're moving a reflection from left to right, you're crossing the y-axis. A reflection over the y-axis. Because this one is inside the parentheses. It controls left and right.
So it's y when it's inside.
Yes, when your negative's inside, it's y.
What do you mean, like inside or outside?
Like, see how there's like this container here? I call it like a container. It's like it's inside this house,
Yeah.
if you will. That's an inside number. Just like these up here were inside something. If you're not inside, you're outside.
But you said the negative is outside.
On this one up here.
What about the other?
This negative is definitely inside, right? It's inside that house.
Why is that in the y-axis?
Because remember that inside things control left and right. And if I'm going to reflect left or right, if I'm going from left to right, which axis did I just cross? The y-axis. That's why it's the y-axis. That's why it's misleading, because most people feel like if you move from left to right, that seems like x, because x goes left and right. But we're crossing, when you go from left to right, what do you have to cross? You have to cross the y-axis to do that.
And to x, you would go like that.
And if it's a vertical like it was on the last one, remember, we went from top to bottom or from bottom to top, in which case I crossed the x-axis. Okay, the only other thing that you need to know about is those conjugates. Remember we did like the conjugates, we had to work with conjugates like 2 plus the square root of 7. What would be that's conjugate? Yeah, it's the same thing, just with a different symbol in between. Remember the conjugates were just the same thing.
So you do first and last only.
Right. Now when you work this, and exactly, if you needed to do this, like let's say you were like, oh, I need to get rid of that in a fraction, just as she said, it's just first times first and last times last if you had to do this. First times first is 2 times 2 is 4. And then the square root of 7 times the square root of 7 would be what?
7.
It just ends up as 7. In this case, a positive times a negative would be like that. Positive times a negative is a negative. This would end up as -3. I just made this up. This wasn't something there. But conjugates were that really easy thing that we dealt with a while back. But you should remember, there's a lot of things in these lessons. So it's not enough to just say, well, I did the review. There's like a lot of stuff in these lessons. The review is just kind of the quick summary of it. It's like, hey, here's some problems that most people miss. But if you want, go back and watch the videos. Go back and go through the homeworks. Go through the lessons there. There's a lot of content there. It can't be summarized down to these just quick problems. But that should be enough to at least get you by there.